Hello everyone, welcome back to Calculus BC. We're in lesson number 31, where we're going to now review area and more importantly, arc length. So in example number 4, I want us to find a couple things that you guys can see here. We want to find the area of the shaded region. We want to set up an integral and find our value using our calculator. And then using arc length, we want to find the perimeter expression. That's going to give us this distance as we travel along the entire shaded region. That also is going to include this curve that we're going to use. And so we're going to use arc length to find this actual expression, and then we're going to use arc length again to find the perimeter value. So actually, how far do we travel if we walk around the shaded region? So area, this is just a quick review for this. I just want to remind you guys that area, we draw ourselves a little rectangle, and no matter where we draw the rectangle in the shaded region, it's always going to be, the top is going to be this curve, the bottom is always going to be this curve. So I know for area, I can integrate this. And I'm going to go ahead and say really quickly that this is supposed to be the y-axis and this is supposed to be the x-axis, because this line here and this line here is just as dark as this. So y-axis, x-axis. So if we're going to integrate this, we're going to go from -2 to +2. So remember, for area, it's always the left bound, the right bound. And that's going to be our top curve, which we're just going to simply call, to save ourselves some time, it's going to be f of x. And we're going to subtract our bottom curve, which is just going to be g of x. And then dx. So that's our expression. You can do that, ladies and gentlemen, again, if we're already identifying which the functions are. So f of x and g of x. So if we plug into our calculator, again, this is 1/2. So you could have absolutely written 1/2 x squared plus 2 here, minus a negative x, and you're going to get 10.667. And so that's going to be the area of this curve. Now, let's talk about the perimeter. Well, the distance here is simply 2. I'm going 2 units, right? 1, 2. So this piece is 2. This piece is 1, 2, 3, 4, 5, 6. So that is going to be 6. That is awesome. That is very easy for us to figure out. Well, now this piece here, we can find out quite simply by using the fact that this is the hypotenuse of a right triangle. And so we have a 1, 2, 3, 4 side here. We have a 1, 2, 3, 4 side here. So not only do we have a right triangle, we also have an isosceles right triangle. So we know from our special right triangles in good old geometry that this is going to be 4 square roots of 2. Now you could absolutely use Pythagorean theorem to find that if you did not quite remember that actual process. And then to find this, well, this is going to be arc length. So we're going to do plus, and we're going to integrate from, again, -2 to 2. And then remember that for arc length, it's going to be 1 plus, and then what we're going to end up doing here is we're going to find the derivative of our function. Remember, arc length is 1 plus the derivative. Now we're using this curve, and so we're finding this derivative. So f prime of x is simply going to be equal to 2 over 2, which is going to be 1, x to the first. So this is our derivative. This derivative of this is just simply going to be x. But remember, guys, we have to take the derivative and we have to square it. We have to square it. And my line is a little too long for that. And then we're going to do dx. So adding all of these numbers up, these 4 things, you're going to get the actual perimeter of this shaded region. And so this is going to end up being, in our graphing calculator, 19.573. All right, so let's do another one. Let's see how we're with the next one. So for example number 5, we're going to find the area of the shaded region, and we're going to find the perimeter of our curve from here, tracing around to right here. So from here all the way up, and then all the way down right here. How long is that? That right there. So for our area, you guys remember that we are going to have to do 2 different integrals because our functions do change. Our top and our bottoms change as we move. If we draw a rectangle this way, our top function is going to be the curve f of x. If we go and draw a rectangle this way, our top function now is going to be the line, which is the x-axis, which we're going to know as f of x is equal to 0. All right. So for our area integral, we're going to integrate. Now, I will tell you guys really quickly that if you were to factor this, because you would have to set this equal to 0 to find these numbers, and you would pull out an x, so you would get 1 is actually 0. And if you were to factor what's remaining, you're going to get -2 as a solution, and you're going to get 3 as a solution. So factoring this is going to give you -2, 0, and 3. So we're just going to go ahead and just, I don't need to show you guys that. So from -2 to 0, our top function is going to be the function f of x. Our bottom function is going to be 0, dx. And then from 0 to 3, our top function is going to be 0, and our bottom function is going to be f of x. Because area, again, is just top minus bottom when it's all in terms of x. And so this is totally legit notation for you guys when you're doing these problems on your test or when you're doing these things on the BC exam. And so if you plug this into your graphing calculator, then you're going to get the value of 21.083. Now, let's look at the perimeter expression. Well, we want to, first of all, also take into account this, right? So it's the whole thing that's doing the shaded region. So I went ahead and did the red to show you about the area. And so now we have to not only incorporate the curve, but we also have to incorporate the fact that we have this distance here because we want the total perimeter of the entire shaded region. So this distance is simply going to be 2. And then this distance right here is going to be 3. So this is very similar to the previous example where we just counted lines. Now, the beautiful thing about this, ladies and gentlemen, is the fact that we don't care. We do not, for arc length, we do not have to set this up into 2 different integrals because if I integrate from -2 to 3 and I go ahead and do 1 plus, and I find my derivative, so f prime of x of my derivative of this right here, it's going to be 3x squared minus 2x minus 6. If I go ahead and just write that down, so 3x squared minus 2x minus 6, and I square it, dx, and I'm going to go ahead just really quickly and just get rid of that so we can not let it get it all jumbled up there. So if I do that, this is going to actually take into account what this function's doing from -2 all the way to +3. So that's actually the beautiful thing about this particular example. And again, that's why it's showing to you in the notes that arc length, literally, is all you do. So when you put this in your calculator, you're going to get 30.399. So this is actually pretty amazing that we can do the problem like that. All right, you guys got it in you. We're going to do one more example, number 6, and this will be the last thing that we're going to do. So for this one, we're going to find the area, and this one, it's right minus left because it's all about our y's. So the first thing we're going to do first is, notice that this one's given to us as x is equal to. So I'm going to go ahead and write this one as x is equal to y plus 1. So this is the equation that I'm going to use. All right, so let's go back over here to area. So area is going to be integrated from, so since now everything's in terms of y, we're going to look at our lower bound and our higher bound. So our lower bound is going to be -2. Our higher bound is going to be 1. And then remember, guys, it's the right curve minus the left curve. So the right curve is going to be our curve right here. So it's going to be 3 minus y squared. We could label this as like f of y and g of y if we want to, but why not just go ahead and just write it like this? So our first function is going to be 3 minus y squared. Our second function, our left curve, it's going to be y plus 1. And then we're going to do dy. And so that's how we're going to find the area of these curves. And I know I just said dy. I hope I said dy, but I wrote dx. So let me go ahead and change that to dy. I have a big tendency of doing that. You could actually integrate this by hand. This would be a non-calculator question, but we're going to go ahead and just use the calculator and find that it's 4.5. Finally, let's go to our perimeter. So the first thing we're going to do is we're going to find the length of this. Well, that's going to be, again, with a right triangle. And so this distance is 1, 2, 3. This distance is 1, 2, 3. So just like again before, this is going to be 3 square root of 2. This distance right here is 3 square root of 2. And then we're going to find this. So we need the arc length formula for this. So we're going to integrate from -2 to 1. The curve that we're finding, is actually going to be right here. So we're going to go ahead and write the square root of 1 plus, and we're going to find the derivative, so x prime. Well, the derivative of 3 is just 0, and the derivative of negative y squared is going to be negative 2y. So we're going to plug in that derivative, and we're going to square it, and we're going to do dy. And then once we plug into our graphing calculator, we're going to get 10.368. Couldn't read the calculator for a second. So 10.368. And that's it. That's an application that you guys will use for arc length with a little bit of review for area thrown in there. So I hope this is helpful, and I will see you guys in the next video.